Alright guys, so let's go ahead and let's fill in this data table since we just got done taking our notes over different types of radiation or nuclear decays. Let's just give us a table that gives us a little bit of a cheat sheet for us. So let's start with alpha. Our symbol for our alpha particle, since it is a helium atom leaving, is just our isotope symbol for helium, which is going to be a 4 on top, the 2 on bottom. Helium. The charge of a helium atom is 0. And we can simply blot alpha particles with a piece of paper. And then we have beta decay or beta radiation. So we have our symbol for beta. A beta decay is electrons. So we have our symbol for an electron. Electrons have no mass, so 0, but they have a -1 charge. And we can do an E for electrons, or, right, you can have the beta symbol for beta. Since it is an electron that is leaving, and electrons have a -1 charge, the charge for this particle is -1. We can block beta radiation with wood, or a thin sheet of metal, like aluminum foil. Lastly, we have gamma. So our gamma radiation symbol can look like this, or it can simply just be the gamma symbol. Since gamma is just energy and light, there is no charge on it, and it can be blocked by concrete or lead. So the quick little data table for us to remember our symbols, our charges, and the ways to block it. Now let's move into looking at nuclear equations and how can we balance these nuclear equations. Let's see if I can move this some for y'all. Okay, so first things first, right, is we want to make this look like an algebra equation, all right? So we're going to rewrite some of these symbols. So first thing that I have is I only want to focus on the numbers, right? So we have 238 here. So I'm going to write 238. Actually, I don't have enough space right there. So let me go ahead and slide this down for y'all. Sorry. Let me leave you enough space. Here we are. So we have 238. So we're going to write 238 up here. The arrow is like the equal sign. We have 234 plus blank, right? So we need to figure out what can be added to 234 to get us 238. If you can't do it in your head, some people are really good at math and they can see automatically what needs to be happening here. But if not, an easy way to do this is we need to subtract 234 from this side and minus 234 from the other. These two cancel each other out. 238 minus 234 leaves you with just 4. So our blank here would have been a 4. So the top number is 4 over here. Now we're going to look at our bottom numbers. We have 92, again, equals 90 plus blank. So again, we can go ahead and subtract 90 from both sides. These cancel each other out. 92 minus 90 is 2. So the bottom number is going to be 2 over here. Now we just need to figure out what symbol goes with this. A 4 on top and a 2 on bottom should be an indication that this is a helium atom. And since a helium atom is being released, this is an indication that this is alpha decay. Moving on to our next one. We're going to do all of these the same way, right? So again, we'll start with our top numbers. We have 14. What's going on? There you go. 14 equals 14 plus blank. What added to 14 gives you 14? The answer here should have just been 0. So a 0 should go on top. Now we do the same thing on the bottom. We have our 6 equals 7 plus blank. So this one, go ahead and subtract 7 from each side. 6 minus 7 should give you -1. So -1 on bottom. The type of symbol that goes with this, if we have a -0 and a -1, this should be an indication that it is an electron that's being released, or your beta symbol, right? So this is a beta decay. Up next, we notice we have a 9 on top. Sorry, I'm having issues with this one. Anyway, I'm just going to write it up top. I can't underline it. We have 9 equals the 9 plus blank. Well, 9 plus what gives us 9? It should be a 0. So 0 on top. On bottom, you have the 4. Again, equals 4 plus blank. 4 plus what gives us 4? It is 0. So this is an indication. We have a 0 on top, a 0 on bottom. So this should be a gamma decay. So remember, if what you have on the left-hand side to start with is the same symbol as the one on the right-hand side of the arrow, then it's always going to be gamma radiation. Moving on to our next one. Here, this one looks a little bit different, but again, set it up like an equation. We're going to start with 198. The arrow is our equal sign. 4 plus blank. So to figure out our blank, we subtract 4 from each side. My 4's cancel out. 198 minus 4 should leave us 194. So 194 on top. On bottom, we have 86. Again, the arrow is the equals. 2 plus blank. We subtract 2 from each side, and we get 84. So 84 is our bottom number. Now, this one's a little bit different because we need to figure out what symbol goes with this. Because we already have this atom right here, and that is a helium atom, so this should go ahead and this should tell us that this is alpha decay. But I want to know what element is it decaying into. So if you remember from way back, this number on bottom, the 84, this is the atomic number on the periodic table, or the top number, right? So I'm going to switch over. I'm going to look at my periodic table, and I am looking for the top number that is 84. So we come over here. See, the top number is 84. So the symbol should be PO. We'll go back to over here, and we have PO. So that is our answer. Alpha decay, it decays into plutonium, and we're done. Here is our last one. So again, let's start with the fact that you see this symbol right here. This is the symbol for a beta particle, so that means this is beta decay that is occurring. Now I need to figure out what are we decaying into, what element are we creating. So we will start with our equation. We have 61, the arrow is our equal sign. We have 0 plus blank. What plus 0 gives us 61? Well, it should be 61. And then we'll do our bottom numbers. We have 28 equals -1 plus blank. So now what we need to do is we're not going to subtract -1, right? Because since it's a -1, to get rid of the -1, we have to have a +1, because a negative and a positive cancel each other out. So we'll do +1 on this side. 28 plus 1 should give you 29. So the bottom number over here should be 29. Again, our bottom number is what tells us what element this is going to be. So I'm looking for 29. I go over to the periodic table. I'm looking for an atomic number of 29, which is the top number, which is this right here. So the symbol is copper that we need. Back, and we're going to write Cu. And that is how you balance nuclear equations. Now go ahead, find your independent practice, complete those 10 problems and take a picture of it and upload it into Google Classroom so I can see your work for today.